بسم الله الرحمن الرحيم والصلاة والسلام على رسول الله الأمين. السلام عليكم ورحمة الله تعالى وبركاته. In this session, I will explain very briefly fast circuit switching. But before to explain fast circuit switching, I would like to remind you what was the disadvantage of the circuit switching. The disadvantage of the circuit switching was that a slot is permanently allocated to a user, and therefore if a user is bursty, that means if he has nothing to transmit for some of the slots, and if he has data to transmit in some other slots, then those slots where he does not have anything to transmit, they will be wasted. So therefore, it was suggested in fast circuit switching that we may do allocation of the slots on demand basis, slot allocation. The idea being that by using some kind of associated signaling, you can allocate the slots on demand basis. Now, the associated signaling works like this, that if a user transmits in a particular slot, and in that slot, he can indicate by some kind of a signaling bit whether he requires some slots in the next consecutive frames or not. If he does not require, then those slots will be released and may be given to a new connection. However, if he requires, then the slots may be allocated to him. That means the network is doing the allocation of the slots on demand basis. The idea being that we utilize the slot in an efficient basis and do not have either wastage of the slot or non-allocation of the slot to a particular user when he needs it. Now, clearly, the efficient allocation of the slots on demand basis will lead to lots of complexity, both in terms of the network management as well as the signaling that needs to accompany the particular user's data for indicating to the networks its demand. Now, therefore, this fast circuit switching was discontinued, or it did not become popular for the transport of the bursty sources, and historically, then fast packet switching, that is another transport mechanism, was evolved and developed. Let us review what kind of information transport modes that we have discussed till now. One mode that we have discussed is circuit switching. We said that circuit switching is inefficient for the bursty sources and also for the transport of those sources where the data rate requirements are different. Then we have studied multi-rate circuit switching. And third, we have studied fast circuit switching. And fourth, we have studied packet switching. Now, if you see these various forms of circuit switching are suitable for the real-time services. On the other hand, the packet switching is suitable for the burst sources, which can tolerate some fixed amount of delays. Another disadvantage of the packet switching is that in any practical statistical multiplexer, the buffer size will be finite or limited. Now, since there is no admission control in packet switching or in statistical multiplexing, it may so happen that the buffer may get full, and when the buffer gets full, the packet may also get dropped. As a result, in packet switching, not only there is a queuing delay, but also there is a packet loss. Now, this kind of transport mechanism, therefore, have not been found to be suitable for the real-time services, which requires some guarantees on delays or packet loss. Obviously, if you want to have a transport mechanism which is efficient for carrying the burst sources, as well as at the same time is capable of transport of real time services, which requires certain quality of services guarantees, then you require a new transport mechanism which has the advantages of both the circuit switching as well as the packet switching. A new transport mechanism to achieve these objectives was proposed, and that was called as asynchronous transfer mode, or ATM, which was also called as fast packet switching. So the principle of fast packet switching or asynchronous transfer mode will be explained in the next video session, where we will go in the details of the ATM switching. So I would like to conclude this video session, and if you have any question, please don't hesitate to ask any questions. So stay tuned and see you in the next video session.